Okay, so let me show you the dataset. This is the orders dataset, and you'll find this dataset in the S3 bucket, or you'll find it in the Google Drive that I have provided. So we have order ID, then customer ID, seller ID, order date, delivery date, order total price, quantity, payment method, discount. So the order ID, we have only 100 rows. So it starts from 1 and ends at 100. So we have only 100 orders. And the customer ID, I think, starts from 10,001 and ends at 10,010. So you'll not find any customer which is more than 10,010. Same is the case with seller also. There are only 20 sellers. Similarly, you have date and other values because we'll be doing a lot of functions. That's why I have mentioned date here. So this is the orders dataset and it contains the order details. Of course, there are not a lot of columns available. These are the only ones that we'll use for the entire exercise. Then you have customers dataset, and we have customer ID, address, zip code, city, state, date of birth, country, email, and phone. Now here we have only 10 customers. And this is the third dataset, which is seller dataset, and there are only 13 records actually, and all the seller IDs are unique. So these are the three datasets that we'll use to load the tables after creating it. And then we'll practice all our SQL statements, functions, etc. using these datasets. Now coming back to the Aurora database. So as you can see, it is up and running. Now what I have to do is that I'll have to connect to this Aurora dataset from my PSQL client or PSQL client. And my PSQL is installed in the EC2 instance. So the way to connect to the database is something like this: psql dash dash host, and here you'll have to mention the endpoint of the Aurora database. So where do you get the endpoint from? Go to the Aurora console and just click on this. So if you click on this, here we have this connectivity and security tab. Now as you can see, there are two endpoints. One is writer and the other one is reader. So I'll select the writer endpoint. Just copy this and mention the host to be that. And then you have port just mention as 5432, and then user is Postgres. So why this user? Because this was the user that we had created while launching the Aurora cluster. If you do not know what the user is, you can find that out. Go to configuration tab here and you'll see the master username. So here the master username is Postgres, so that's why I'm using it. So as you can see, I'm not able to connect to the database, and I can wait for some time. It will give me error as connect timeout. The reason is that we'll have to do something else in the security group also. So there's a security group associated with the Aurora cluster, and we'll have to make some modifications in that security group. So what you do is that select this particular instance. So if you see in the role, we have regional cluster and we have writer instance. So select the writer instance. So select the connectivity and security in this instance and go to security. Here it is showing you a VPC security group and it is shown as default. So just click on this, open it in a new tab and just follow along. If you want to know about VPC and security group, please go through the chapter of VPC and security group. So select this security group, which is the default one. Click on inbound rules and click on edit inbound rules. You can't change this one. Click on add rule, and here in the type, just select all traffic. And here the source should be anywhere IPv4, and then click on save rules. So now it is done, and as you can see, it was timed out. Now if I try again, I'll have to provide the password. This is the same password that you had mentioned while creating the Aurora cluster. And now I should be able to log into the Aurora PostgreSQL cluster. So as you can see, it shows Postgres. This is the name of the database. And I can look at all the databases by / and then L. And these are the databases. We have this database 3 IAM underscore SQL underscore DB. And this is the database that we had created while launching the Aurora cluster. First, we'll have to connect to this database, or let us go ahead and create a database on our own. So the syntax is create database and the name of the database, which is SQL basics DB. So as you can see, the database has been created because the output is actually the command. Type /l again. As you can see, the SQL basics database has been created. Now I can create one more database, let's say SQL underscore basics 2 or SQL basics, let's say, and I'll be able to see both the databases, SQL basics and SQL basics DB. But I would not need two databases for this exercise. So let me go ahead and drop the database SQL basics. And this is how we drop a database. So after the database is created, I'll have to go inside of the database to create multiple schemas. So if you remember the diagram, which is this one, and inside of the database, I can create multiple schemas. So I could have done the same for the other database also. But in this case, I have only one database. So let me connect to the database and then I'll create multiple schemas and tables inside of this database. So to do that, we type /c and then type the name of the database. Now I'm connected to the database. So it says you are now connected to database SQL basics DB as user Postgres. Now as you can see here, the name has changed. Earlier it was Postgres, which was the database. That is the default database that you connect to. Now I have connected to SQL basics DB. And all the operations would be done in this DB. So I can go ahead and create schema. So remember one thing, that the concept of schema and databases are different in Postgres. But if you use MySQL, schema and database are same. So there's no different schema in MySQL. Database itself is the schema. Now here I can go ahead and create schema. And let's say the name of the schema is db underscore object. So the schema has been created. Let me create one more schema and the name would be db underscore test. So both the schemas have been created. Now we can use this command /dn to look at the different schemas that we have. So the one that I created, db underscore obj, then I created db underscore test. Then by default also we get a schema called public schema. So what happens is that now we'll have to create all the tables in one of the schemas like db underscore obj or db underscore test. But if we do not mention a schema while creating the tables are created in public schema by default. Now the first thing that I'll do is that I'll create the customers table and I'll create that in db underscore obj schema. So to do that, just mention set search underscore path as db underscore obj, and now I'll create this customer table. So the customer id is the integer, address is text, zip code, phone, etc. And I also have created the constraint customers underscore pk, where customer id is the primary key. Don't worry about this syntax. If you do a copy and paste, this is how PostgreSQL will interpret that. That is perfectly fine. And you'll find these commands in the command sheet also. So you can copy it from the command sheet and paste it here. But I have created this table, so I can type /d to look at the tables that have been created. So the table is customers and the schema is db underscore obj. I can also type /d plus and just mention customers and it will show me the definition of the table. It also tells us the primary key that has been created, and the primary key is customer id. Forget about B tree and etc. I'm not going to talk about the indexes and B trees. This is mainly for SQL developer course. Indexes and B trees would make sense for administrators. So I'll not talk about these things here. Anyway, so if you type /d plus and then customers, you can see the definition of the table. Now let me go ahead and create the other tables. I'll create sellers table and then finally orders table. Now why am I creating the customers table first and sellers table second and then the orders table? Because I am going to reference the customers table and the sellers table in the orders table. So to reference that, I need to have these two tables beforehand. These two tables should be there before referencing them. So that's why I'm creating these two tables first. And this is the second table, and seems like there is some syntax error. So if you click on left arrow, then you can go to that place and fix the syntax. So the reason was there was no comma here. So that's why it errored out. So now we have created the sellers table also. And then finally we'll create the orders table. To clear the screen, you can type Ctrl L, and this is the definition. So as you can see, I am creating a primary key with order ID. Then I'm creating two relations, or relations with two tables. The first one is orders cust fk, customer foreign key, and the foreign key is customer ID, which references customers table and the column customer ID. Same is the case with another referential integrity. The name of the constraint or the name of the integrity is orders underscore seller underscore fk. The foreign key is seller ID, which is this one, and it references the sellers table and the column seller ID. So we created the sellers table here, and this is the primary key of the sellers table. So that's what it is referencing. Remember, this particular column should be primary key of the main table. Alright, so now I can type this and enter. Okay, there's some error here also. And this term, what have I done is I have put an added comma. What happened here is that I created the customer table with customer ID. But in the references, I have mentioned cust ID, which actually does not exist. So I'll have to use customer ID. So let me fix this. So it is customer ID in the customers table, and it is customer ID in the orders table also. So now it should go ahead and get created, and if I do a /d, I can see all the tables that have been created. Let me try to look at the definition of orders table, and it will show me the columns, the data types, the primary key, the foreign key, etc. Right, so this is how we create objects. So right now I have just created three tables, and then I have related them using referential integrities or primary keys and foreign keys. So all the tables have been created, but we do not have any data in these tables. And what I'll do is that I'll load the records from S3 file. So I have this S3 bucket created, and the name of the bucket is 3IAM SQL dataset, and here I have these three CSV files: customers SQL dataset, orders SQL dataset, and seller SQL dataset. So what I'll do now is that I will go ahead and load the three tables that I have created using these files. And to do that, first what I'll have to do is I'll go to Aurora and go to connectivity and security, but not in the instance, at the cluster level. So select the cluster level and click on connectivity and security. And at the bottom, we have something called manage IAM roles. So if you remember, we had created a new IAM role, which is 3IAM S3 role for Aurora SQL. So this is the role that I had created at the beginning, and I had added this access. So I'll have to attach this role to the cluster to load the tables. In the manage IAM roles section, we have this option called add IAM roles to this cluster. Click here and you should be able to see the role, and this is the one, 3IAM S3 role for Aurora SQL. And in feature, select as S3 import and then click on add role. And it will take some time for the status to become active. So once the status is active, we can go ahead and load the tables from the S3 files using certain commands. As you can see, the status is active now. Now I can go back to the database server and this is my database server. First thing that I have to do is that I'll have to run this command, create extension AWS underscore S3, and then mention cascade. So just run this command. It will say that installing required extension AWS Commons. So once this is done, now we should be able to load the files to this particular tables, customers, orders, and sellers. Let's go ahead and do that. So the extension creation is done and we have the files in this S3 bucket. The name of the bucket is 3IAM SQL dataset. You can create your own bucket and then these are the different file names. So what am I going to do is that I'll have to load these files to individual tables. So of course I'll have to start with customers or sellers. Again, any order I can load seller first and then customers, or customers first and then seller. But I have to make sure that these two are loaded before orders, because orders table has a relationship with customers table. It also has a relationship with sellers table. So that's why you have to load these two tables first. But let's say the table customers also had a relationship with seller but not order, then we would have to load the seller table first, then customers, and then orders. And this is the command. So let me make you understand what the command is. So we'll have to run select followed by AWS underscore S3 dot table import from S3. So it is a tool provided by Aurora to load data from S3 files to a table directly. And then we open a bracket and then close it. And inside of this bracket, the first one is the name of the table. And the name of the table is customers. And then mention empty here. So typically what happens is that we mention the column names, but if you want to load all the columns, we keep it empty. Then we mention the delimiter, and the delimiter is comma, double quotes here. So again, don't worry about it. The command is given in the command sheet. Then after that, we have one more function, AWS underscore commons dot create underscore S3 underscore URI. It also starts with a bracket and then ends here. The first thing in quotes is the name of the bucket, and the name of my bucket is 3IAM SQL dataset, and that's what I have mentioned here. Then the name of the file, which is customers underscore SQL underscore dataset dot CSV, and the region where this bucket is. And now if I press enter, and if there are no syntax errors, the table should be loaded, and it seems like there are syntax errors. All right, now the error is because this particular bucket, right, 3IAM SQL dataset, is in a different region. This is not in US East 2. The bucket is in US East 1 region. Let me show you. This is the bucket 3IAM SQL dataset, and it has been created in US East 1 region. So that's why I'll have to mention the proper region here. Again, the problem is that, let me open the file. So this is the file. So as you can see, it has a header also, and this is a CSV file, right? So what I mentioned, I did not mention that the file is CSV, and I did not mention that there is a header. So whenever it is trying to load customer underscore ID, this is not an integer. This is a string data type or a character data. Not data type, sorry, this is a character data. But while defining the table, I mentioned that the customers underscore ID data type is integer. So that's why when Postgres is trying to load the string data type into a column whose data type is integer, it is creating error. So I'll have to fix it. Again, it's not that complicated. The problem is that it is very syntax heavy. The first thing is that I'll have to mention header, and I'll have to mention format also. So the format should be CSV and then header and then delimiter. Again, there were some syntactical errors. So I had mentioned bracket here. Let's see whether it works or not. If it does not work, then again we'll fix it. These are all related to syntax. There's no concept here as such. Again, I've got an error. It says syntax error near format. So this is the final syntax that you have to use to load the table. And what I had to do is that I had to remove the header from the files because I cannot mention format CSV and header together. So now it should run, and it says that there are duplicate key exists in the table in the file. So the key also mentions the key is 10008, which is perfectly fine. It seems like as we have created a primary key on customer ID, we have two values with 10008. Let's go and take a look at the file. I have removed all the duplicates from the file. So now if there are no duplicate values, it has been imported. So 8 rows have been imported to the customers table. Now let me go ahead and create the other tables. Now I will import the sellers table, and the name of the table is sellers, but the name of the dataset is seller underscore SQL underscore dataset. So again, there are some duplicate values like seller ID with 2019. So I'll fix this and then come back. So after removing the duplicates, 12 rows were imported in the sellers dataset. And finally, I'll upload the orders dataset with 100 rows. I'm loading the table orders. The format is CSV and the bucket name is same and the file name is orders underscore SQL underscore dataset. The order table has been loaded with 100 rows, and what I did was I inserted only the primary key values in sellers and customers table. So I'll give you the commands in the command sheet also. Go ahead and insert these values and then run the or import the file into orders table. So that's how you can load the tables in Aurora Postgres from files in S3. So as the loading is done, now what we'll do, we'll go ahead and start executing the CRUD operations or the data operations. Before going further, let me show you some of the alter commands that we run on a table. For example, let's say if you want to add a column or remove a column or change the data type of a column, etc. And again, I'll log into the database or basically the cluster. And now I'm connected to the Aurora PostgreSQL cluster or database, and I am logged in as PostgreSQL database. And then I'll have to connect to the SQL Basics DB that we have been using so far. Now I'm connected to SQL Basics DB, but if you type /d, you'll not see any tables. Even though we created multiple tables, it is not showing anything. Why that is the case? Because it is showing tables from the public schema, and we did not create the tables in public schema. We created all the tables in db underscore obj schema. So if you type /dn, these are the schema that we have: AWS Commons, AWS S3, db obj, db test, and db and public. So by default, if you type /d, it'll show you the tables from the public schema. So that's why you'll have to set the search path, search underscore path. It means that we'll be using a particular schema. Using this search path, we change the schema that we work on. So now currently, instead of public schema, I am working with db underscore obj schema. Now if I type /d, I'll be able to see all the tables. So we created this customers tables, orders tables, and sellers tables. Sellers table rather. Alright, so now what will I do? First, I'll create a new table which is similar to, let's say, orders table. And to do that, you do not have to define the entire, or you do not have to write the entire create table command, because I will create an orders, let's say, duplicate table which is similar to orders table. For that, we can use something called like. Now if I mention like orders, it will create the table orders underscore duplicate, which is just like the orders table. There's a syntax difference in the like, so you'll have to mention the like orders in the bracket. So now if we take a look at the tables, this orders duplicate table has been created, and if we want, we can take a look at the columns also. It has the exact same columns: order ID, customer ID, etc. So now the table has been created. Now we'll have to insert data into the table. So what you do, insert into orders underscore duplicate and select star from orders, because we know that the number of records are exactly same, the number of columns are exactly same rather. So we can insert the records, and as you can see 100 records have been inserted. Now what will I do? We will go ahead and make some changes in this particular table. So first let's check the schema of orders duplicate, and this is the schema. So what am I going to do? I'll be adding a particular column in this table, and this is the column that I'm adding, product ID, and the data type is integer. So now if I again look at the table structure, I should be able to see product ID getting added, but product ID should not have any value. If I do a select star, I'll talk about select star and limit, etc. So as you can see, product ID is actually blank. So this is the value for product ID, which is in the second line. So it's all blank. So that means there's no value for product ID, which makes sense because I've just added the column in this particular table, and I did not make any change or did not insert any value in product ID. So that's why I do not see any value in product ID column. Next, what will I do is that I'll remove this payment method column because for some reason, let's say this is not needed. So let us go ahead and drop this particular column, and the command is alter table orders duplicate drop column followed by the column name. So now the column has been dropped, and if I look at the structure of the table, I should not be able to see payment method anymore. So payment method has been removed, and let's try to look at some of the values. And as you can see, payment method is completely gone. The value is not there. And as you can see, product ID is anywhere blank. So we have added one column and we have removed one column. Then what will I do is that I want to rename a column because let's say some column name does not conform to the value that it holds. For example, let's say price. So this is seems like price of an individual item, but that is not the case. It is the price of all the items for a particular order. So it makes sense to change the price to total price, and the command is alter table rename column, the old column name and the new column name. So now if I change it and look at the structure, as you can see, the price has changed to total price, and if I select records also, it will show total price as the name of the column. And now what will I do is that I'll change the data type of total price, because let's say I had put 8,2, which means there can be 6 digits before the decimal point and 2 digits after the decimal point. But let's say the application or the website has become famous, so the number of orders can get increased and the price can be also very high, because let's say there are some high value items that the application or the website is selling. So that's why I'll have to change the data type of, let's say, total price. Now current value is numeric 8,2, and what will I do is I will alter the column and I'll change the total price data type, and this is how we do it. Set the data type decimal 10,2. So this is done now, and if I look at the structure again, as you can see, the data type has changed and it does not have any impact on the value of the columns. The value of the columns, values of the column remain the same. So this is how we can change a particular table to add column, remove column, change data type, etc. There are a lot of other things also that can be done using alter table statement, but those are a little advanced and I do not want to go into the details of those. Now, as the work is done, so let me go ahead and drop this table, orders duplicate, and it is very simple. Drop table followed by table name, and now the table has been dropped and we cannot see orders duplicate table anymore. So this is how the alter table statements work and drop table statements work.